Assalamualaikum and good day everyone. I am Khadijah from the College of Computing, Informatics and Media UiTM, and today I would like to present a study entitled Hospital Bed Allocation using 3-stage weighted optimization method for government hospital in Pulau Pinang. First thing first, let me introduce a little bit about the study. The main issue that has led to this study is the resource imbalance, specifically bed allocation across the wards in the hospital. Some departments have more beds but less patients, while other departments have less beds but more patients. This has led to a longer waiting time between the patient's arrival and their admission to the ward. In order to solve the issue, this study have put together 3 objectives to be achieved. The first one is to simulate the arrival of patients to the hospital and the admission of each selected department. The second one is to measure turns of each department in the hospital based on the weightage that computed according to bed occupancy rate, patient's length of stay, patient's arrival rates, and bed operation costs. The third one is to formulate a goal programming model that maximizes the usage of limited hospital bed resources and minimize the operating costs. Now, we will go through an overview of the literature materials referred while completing this study. There are 5 previous studies that are mainly referred to. 1. Optimal Bed Allocation in Hospitals by Lee et al. In 2009. 2. A goal programming model for reallocation of hospitals' inpatient beds by Ataullah et al. In 2013. 3. Reallocation of Shafa Hospital beds in Kerman using goal programming by Mehrul Hassani et al. In 2016. 4. Optimization model for capacity management and bed scheduling for hospital by Sitepu et al. In 2018. And 5. A data-driven hybrid 3-stage framework for hospital bed allocation, a case study in a large tertiary hospital in China by Luo et al. In 2019. The similarities of all 5 studies were the aim to allocate optimal number of beds to the wards. However, the approach used are different. 3 of them applied goal programming model along with different optimization software, while the other 2 used integer programming model. Sitepu et al. Was the only study that covers about cost minimization, while Luo et al. Implemented hybrid 3-stage optimization, which inspired this study. Next, let us go through the steps and methods used throughout the study. The research begins with data collection, then data analysis, and after that the 3-stage optimization that consists of data simulation, weightage evaluation, and weighted optimization. The 3 stages were designed to achieve objective 1 and 3 respectively. Lastly, it is finished with a result analysis. For the data collection process, the sample chosen was Seberang Jaya Hospital. The instrument used was a secondary data, which is 2018 Seberang Jaya Hospital annual report that can be obtained from the hospital website. The data analysis process consists of data cleaning, converting information, and also computing useful information. Next is the 3-stage optimization. As I have mentioned earlier, the 3-stage framework was modified from a study by Luo et al. In 2019. Luo et al. Implemented data analysis, data simulation, and optimization, while this study implemented data simulation, weightage evaluation, and weighted optimization. For the first stage in 3-stage framework, which is data simulation, the software used is Arena Simulation software. It aims to fulfill the first research objective, which is to simulate patients' arrivals and admissions into departments. The significance of each is for understanding the flow of patient stay in the wards according to the departments from admission until discharge. The second stage, which is the weight evaluation, aims to fulfill the second research objective, which is to measure the importance of each department in the hospital based on the computed weightage. The criteria that will be measured for the evaluation is patients' rates as referred to Lee et al., bed occupancy rate BOR, and average length of stay ALOS as referred to Luo et al., and bed operation cost BOC as referred to Sitapu et al. There are three phases for the weight evaluation. The first one is to measure the department weights based on the four criteria, which are the patient arrival rates, bed occupancy rate, average length of stay, and bed operation cost by using the formula WIC equals to CI divided by the summation of C. WIC is the weight of department I based on criteria C, while CI is the value of a criteria for department I. The second phase is to compute the weight value of each department I by summing up the four criteria weights of department I. Lastly, to obtain the overall weightage of department I, the department's weight value is divided by the total weight values of all departments. The third stage, weighted optimization. There are two goals to be achieved using the goal programming model, which the first one is to minimize the idle beds, while the second one is to minimize the operation cost. The objective function for the first goal was referred to Ata'Allah et al., while the objective function for the second goal was referred to Sitapu et al. The optimization model then is executed using Excel solver. The objective function for both goals can be written as follows. Min Z equals to the summation of Wi minus Dyi minus plus Wi plus Dyi plus DYH plus DCH minus plus DCH plus. Wi is the weight of department I, Dyi is the goal number of beds in department I, DYH is the goal number of beds in the whole hospital, and DCH is the goal bed operation cost for the whole hospital. The plus or the minus symbol on top of the meters indicates the overachievement and the underachievement of the goals respectively. The objective function is subject to the following constraints. First, the total number of beds in each department must be equal to their targeted number of beds. Second, the total number of beds in all departments must be equal to the total number of beds in the hospital. Third, the total cost from each department must be within the budget allocated by the government. And lastly, non-negative constraint, which indicates the number of beds must be greater than or equal to 0. For the last step, result analysis, the software used is SPSS Analytical Tools. It is to determine the factors that influence the changes in the number of beds suggested, either patients' arrival rates, BOR, ALOS, or BOC. Now, let's take a look at the results of implementing the three-stage weighted optimization framework. The simulation model built on Arena software shows the flow of patients' admission from arrival until discharge. The patient's arrival was simulated for a 30-day period. The result shows the difference between the number of admitted and discharged patients, which means there are patients that are unable to secure a bed. The three phases for weightage evaluation was implemented to obtain this result. Column 2 until column 5 in this table is the result of phase 1, which are the department's weight based on the four criteria. Column 6 is the result of phase 2, which is the total of all weight for each department, and the column 7 is from phase 3, which is the overall weightage result. The weightage of the departments can be categorized into three priority categories: high, medium, and low priority. Each category bears different underachievement and overachievement weight. The following table shows the result of the optimization using Excel solver as compared to the initial goals. Based on the number of beds suggested by Excel solver, the total number of hospital beds obtained was 379, which is 10.17% higher than the actual target of total 344 beds. However, with that number of beds, the total cost obtained was exactly equal to the budget allocated by the government, which is 44,695 ringgit. Hence, the solution is optimal for the hospital since it does exceed the allocated budget. The result obtained was then analysed using SPSS analytical tools. From the table, the Pearson correlation value for the arrival rates is the highest among the four criteria. The value 0.789 indicates a strong positive correlation between the weight arrival rates and the bed numbers. We have arrived at the end of the presentation. Thus, to conclude, the goals of the study, which are to minimize unoccupied beds and bed operation costs (BOC), are solved by the three-stage goal programming model and implemented on Excel solver. The result of the statistical analysis shows that patient arrival rates have the most influence on the bed allocations in each department. For future researcher, there are many more elements that can be explored regarding hospital bed allocations, either in Malaysia or other countries. Some enhancements that can be made are in terms of parameters, objective function, weightage evaluation, and also software application. That's all from me. Thank you for your attention and have a great day, everyone.